So we have a geometric sequence with a second term of 30, a fifth term of negative 468.75. We want to find the general term as well as the sum of the first 5 terms. All right, so one thing I always find helpful is to first make it a bit more explicit how this is a sequence or a series. And so we know the second term, we don't know the first term, so I'll just put a blank for the first term. The second term we know is 30. We don't know the third term, the fourth term, but we know the fifth term is negative 468.75. And this just makes it a little more formal and familiar, really, how this is a sequence. All right, now the common ratio which we need to find is what we multiply as we go from each term to the next this way. Now, I can figure out the common ratio fairly quickly by just looking at what I've written down. I can see if I start at 30 and I multiply by r 3 times, 1, 2, 3, I end up with negative 468.75. So I can make that a bit more explicit and literally write down, if I take 30 and multiply by r 3 times, not 3r, r to the power of 3, I know I'm going to get negative 468.75. And I can always do something similar in situations like this. And now I want to solve for r, should just take 2 steps, divide both sides by 30. We get r cubed equals negative 15 and change. And then find the cube root of both sides. So r will be the cube root of this somewhat messy number. Keep in mind the cube root of a negative number is possible. The square root of a negative number is an imaginary number or not a real number, but in this case we get exactly negative 2.5. So there's our common ratio, always a crucially important value to figure out. And so now I can answer half the question to find the general term. Well, let me first write down the general form of the general term. And now we kind of know everything we need here. We know our, oh, sorry, I take that back. I lied. We don't yet know our first term. We still need to figure out our first term right here, which I can find out really quickly now that I know the common ratio is negative 2.5. So I now know when I go from here to here, I multiply by 2.5. Well, I want to go backwards. And so that means I want to divide by 2.5. And so that first term must be the same as 30 divided by 2.5, which a quick calculation tells me that's negative 12. And if you're unsure, just double check, go this way, multiply by 2.5, and you do indeed get to 30. So now I have everything I need to find the general term here. And so the general term will be negative 12. The common ratio we saw is negative 2.5. Those brackets, be very careful with it, to the power of n minus 1. And that's our general geometric term. That's it. I want to find the sum of all these terms. And so the sum of a geometric series, there's 2 basic forms we can look at here. They're the exact same thing, just depends if what you like better. You can either have r to the power of n minus 1, and then you divide by r minus 1 the denominator, or you can have it the other way around, and you have the other way around here. It does not really matter, just don't mix the 2 up. I'll just go with the first one and be consistent with that. And we know everything we need here. We know our first term, again, is negative 12. The common ratio we figured a while ago was negative 2.5. Really important to have these extra set of brackets around here to the power of n. Keep in mind, if we don't have those extra brackets there, if we just write this, 2.5 to the power of n, that is not the same as negative 2.5 to the power of n. Obviously that's not the same. What I meant to say was this is not the same as this. That's what I meant to say. And they're not the same. This right here, this means 2.5 to the power of n, all made negative. This here means negative 2.5 times itself n times. And always got to be really careful with that. And so those brackets there I put in fact, I'll just make it a little bit neater, are really, really important. We know there's 5 terms here, and that's pretty much it. The rest is just arithmetic. And be careful, there's a lot of brackets going on here. We want to be careful with our calculator, but if we do all the calculations properly, we should get negative 338.25. All right, So we have some sig notation here, and we want to use what we've learned about geometric sequences to evaluate this. And so our first step is to remember or remind ourselves what this means. So this, again, represents a sum of a number of similar terms. In this case, we have terms that are all in the form 2 times 4 to the power of r, but that r starts at 2 and works its way up to 8. And so if I just write down the first few terms, my first term in this case is 2 times 4 to the power of 2. Plus, that would be my first term. My second term is almost the same. It's 2 times 4 to the power of 3. And that r value keeps working its way up. Plus 2 times 4 to the power of 4. It wouldn't take me too long to write them all out, but I'm feeling a little bit lazy as usual, so I'll just skip to the last term, which will be 2 times 4 to the power of 8. Now, I'm going to evaluate a few of these. I don't have to, but just to make it feel a little more concrete. For example, that first term is 2 times 16, which is 32. The second term is 2 times 64, which is 128, and so on. And so I can clearly see the common ratio. Either if I look from here, I can see with a quick calculation, this is multiplying by 4, or I can see it right from here. The only difference from each term to the next is I multiply by an extra 4. So there's my common ratio. 4, or multiplying by 4. As well, I need to be clear about the number of terms. A really common mistake is to look at this and go, well, I'm starting at 2, I'm ending up at 8, so that's a difference of 6, so there must be 6 terms. But that's wrong. There's actually 7 terms here. How do I know? Well, I could just count, and if you just count on your fingers, 2, 3, 4, 5, 6, 7, 8, you've counted 7 numbers. And what we'll always find is that the number of terms is always the same as the final value minus the first value plus 1. There's always 1 extra. If you're ever unsure, just count them out. It's only 7 in this case, but it's really easy to make the mistake and kind of jump to a conclusion a little too quickly. There's 7 terms here, not 6. So with that said, I now have pretty much everything I need to find this sum. I really want to find the sum of this geometric series here. I can see the first term, I can see the common ratio, I know there's 7 terms, so I'm going to jump back to this fairly standard formula I've used already. And so in this case, my first term actually is 32. The common ratio is 4. Again, there's 7 terms. And almost the same on the bottom, r minus 1, so 4 minus 1. Again, be careful when you calculate these things. Depends on how confident you are with your calculator, and you want to become confident with your calculator in this course. You should get 174,752. All right, last question. The sum of the first 10 terms of a geometric sequence is 1,364, and the 2 consecutive terms in the sequence are 32 followed by negative 64. Keep in mind, I don't know which terms those are. I just know in this sequence, one of the terms is 32 and the next one is negative 64. Determine the value of the first term, so we're trying to find that. All right, well, one thing I can see right away is that if we're going from 32 followed by 64, I can tell that the common ratio must be negative 2, multiplying by negative 2. 32 times negative 2 is negative 64. So I know the common ratio right away. I also know there's 10 terms. That's always good to know. And I know that in a geometric sequence, it all adds up to 1,364 if I add these 10 terms. So to make this a little more formal, what I know is S10 equals 1,364. I know the common ratio is negative 2, and I know there's 10 terms. Which means just from that, I can now solve using my geometric sequence formula. I can solve my answer quite quickly. And again, the formula I'm referring to is the same one right here. And again, while there's 2 different forms of it, I'm just being boring and always using the same one. I don't see the point in going back and forth. They're almost the same. And so I know just about everything here. I know the sum is 1,364. I don't know the first term. That's what we're trying to figure out. But I know everything else. Common ratio is negative 2. Now I got to be careful again with these brackets here. It's all of negative 2 being raised to the power of n being the number of terms, which is positive 10, minus 1, all over, oh, it helps if I write down my formula properly, shouldn't be an n right there, to just negative 2 minus 1. If you're going to make a mistake here, and it's very easy to make a mistake here, it's going to be evaluating this part. So I would just be a little bit careful here, but as well, Now to do this in a few steps, I'll just clean this up a little bit. 1,364 equals the first term times 1,023. That's negative 2 to the power of 10. Again, negative 2 to the power of 10 is going to be a positive number because we're multiplying by a negative 10 times, an even number of times. Then we take away 1, divide by negative 3 here. Negative 2 take away 1. And I'm just going to multiply both sides by negative 3 at first to solve this algebraically. And so I get negative 4,092 on one side and just 1,023 times our mystery first term on this side. Divide both sides by 1,023. And we get exactly negative 4. So our first term is negative 4. Keep in mind our first term, in this case, is a nice whole number, a negative value. But for terms can be negatives, terms can be decimals and fractions. Term numbers, we can never have a negative 4 as a term number. But as a term, that's okay. So the first term here is negative 4.